Welcome to this episode of Robert's Creative Chronicles. So today we'll be doing machine drawing, and the machine drawing we are going to do today is the bearing assembly. So before I start this video, since it's machine drawing, it takes time. So this machine drawing will be divided into 3 parts. This episode is the first part. After this part, there will be 2 other parts. So there will be 3 parts of this machine drawing. This first part will contain the elevation. The second part will contain the end view, and the third part will contain the plan. The details for a 76mm diameter bearing are shown on page 232. Draw half full size the following views of the complete assembly: a sectional front elevation on BB, a sectional plan view on AA, an outside end view looking on the bearing cap. So here is the bearing assembly, and we are asked to draw half full size. So I've already divided all the dimensions we are going to use by 2 to make things faster. So this is third angle projection. So now in third angle projection, you know that the elevation will be down, the plan will be up, and the end view will be at the side of the elevation. So let's start with the elevation. Now the elevation but it's not a normal elevation, it's a sectional front elevation on BB. So where is BB? Here is BB. So we are going to draw this sectional elevation around this BB is a section. It's a cutting plane. So the sectional front elevation is like the part you are going to see when you divide this plane into 2. When you divide this plan into 2. So what we are going to see, that's what we are going to draw. That's the sectional front elevation. It's not like the normal elevation. So let's proceed to it. So now this is the elevation. So we'll start drawing this. So we'll draw this line first. The distance from here to here is 130. So we're going to draw 130, 12, and 12. So we're going to measure 130. Let's use this. This is 130. This is 130. Then 12. And 12. And we have measured 130, 12, and 12. Then here also, here is 20. So we'll come back 10. That is 10. We'll come back 10. So here is what is 12 and 12. So we'll come back 10 here. Then we'll bring them down with thin lines. So the 130 measurement started from where? From here. So, but this one is a center line. So we'll change it to a center line. So it has been changed to a center line. Then on this line, from here, we're going to measure what? 50, 38. We're going to measure 50 and 38. So it's from these two. This is 12, 12. So from here, 50, then 38. Then we are going to come down 3. So it will be what? 1, 2, 0.3. Then we are going to measure the height. The height is what? Is 92. So we'll measure 92. This is 92. And this one is a cutting plane because here is thickened, here is thickened, so it's a cutting plane. But we'll thicken here at the end, maybe when we finish. Then here, we are going to what? Measure a diameter of 48. So we'll draw it. So diameter 48, to measure it, we'll have to measure the radius of what? 24. This is the radius of what? This is the radius of what? 24. This is the radius of what? 24. So then, and we have to know the line we're going to put it on. It's the center line. So this is the center line. So also here is 122. So we measure the radius of what? 30.5. Then you see you extend it. So this one is what? Is 118. So half of 118 is what? Is 59. 59. Since this is here, we'll put it here and mark it. So we'll put it here and mark it like this. So then we'll join it. Then we can join here now. And also we can join here. So now let's get the top first. And we can tick in here small. Then here the radius is what? The radius here is 3. So the major radius of 3 is 3. We'll put it here. Then we'll put it here. We'll cut here. Then we'll put it here. Then we'll cut here. Then see from this point, we will draw it. So you see this is the curve. Likewise, we'll do it here. But since the radius is very small, we can use our hand. And this also be something like this. You can see. You can see. So then we'll join here. So but this is the proper way to do it. So then here we'll join it to here, but it will be to the 24, the first 24, that is first 12. So not here, this one is 10 backward. So we'll join it to here. Then now there's a radius here. The radius is what? Now there's a radius here. The radius is what? Is 20. So we are going to create the radius here, 20. But since we're using half scale, it's 10. So we'll measure 10. So this is 10. So we'll put it here where these two lines meet. We'll cut here. Then with the same radius, we're going to put it here. We'll cut here. Then here also, we'll cut here. Then from here, then using the same radius, we'll draw the curve. Then we'll join it. So then here we'll also join it. Then, so here we'll draw the radius of here. Here is what? The radius is 50. So we're going to use 50. So we'll open 50. This is 50. So from here, we'll draw it. The height here is what? It's 16. So we'll measure 16 downward from the highest edge. So here, downward here will be what? 16. This is 16. And we'll join it. Then, here is what? Here is 10. So we'll measure 10. Then we'll join it. Then here, we're going to put the radius 10. All of this, the radius is 10. So we're going to put the radius here and here. Here and where? And here. And even here. So we'll measure 10. Or we can just even use this measurement since it's the same thing. It's 10. Then from here, we're going to cut. And also we'll cut here. And from here, we'll cut. Then from here, then also here, using the same radius 10, we'll put it at this point. We'll draw. We'll draw then from here. Then we put it here. When we put it here, you will notice that it will cut outside this line. So you reduce the radius small until it's on this curve. So you reduce the radius until it touches this curve. Then you draw it. And if you measure it, you will see that it's still 10. You see it's still 10. Likewise here, you do the same thing we did here. So now we'll get the curve here. The curve here is what? It's a radius of 95. So from here, we'll draw a radius of 95 from somewhere here. So to get that, we'll measure 95. So this is 95. Then using this radius 95, you see this curve starts from somewhere here, a little away from this. So we will start from here. Then the curve ends here, a little above this line. So we'll stop here. So From that point, from this point, we will draw an arc. From here also, we will draw an arc. So this is the meeting point. So from here, we'll draw it. Then, in the same way, from this point, we'll reduce it a little bit to touch here. Then we'll draw it. So here, we also come. Here, the same radius 10. So we'll measure 10 here. Then the curve, we'll assume it starts from here. We'll draw a curve. Then we'll assume it ends here. Then from this point, then we'll bring out here a little bit. Then can also bring out this line a little bit. So what remains? Then this one. This one will just bring this set square. We'll put it here. The width was not specified, so we can just draw it here like this. Then, well, this one was specified. This one is 8. So from the center line, we'll measure this. This is 29. So we can roughly say it's 30. Then half of 30 is 15. So the center point will be a little above 15 here. Here. So this is the center line. So from this center, we will measure 4, 4. This is what? 4, 4. Then here the radius is what? Is 5. So we'll measure 5. So this is it. So we know that this is a bearing assembly. I know that this is the hanger bracket. This is the bearing cap. This is the top bearing step. This brace, you know that this brace will enter here because if you check it, this is 172 CRS. You also see 172 here. If you check it again, you see 236. Here is 236 here. Here is 96. Here is 122. Here is 96. Here is 122. And you can even see the shape. So this will enter here. So we'll assemble this into here. And then we need two M20 stud. But since we're using half dimension, we'll use M10 stud. So we'll also construct two studs entering here, bolting these two components together. So that's what we're going to draw here. So now, from this is the center line. So from here to here is what? Is 19, then 25. So this is 19, this is 25. So from here, from the center line, we'll get 19. So here is 19, then 25. Or let me use this one. This is 19. Then here is 25. So now, we'll extend this circle. These two circles, we'll extend them. Likewise here. You see, we're now putting them together now. So then, we'll draw this line. The width is here already. So the width ends here, 19. From here is 19. You can see it, 19. So, we'll extend the line here. And then we'll bring it down. Then we'll bring it down. And draw the piece. So now, the circle here is what? Radius of 76. So we're going to draw a radius of 76. This is 76. So from this point, we'll mark this point. We also mark. Then from here, we'll draw it. This center point is what? Is the distance between the two center points is what? Is 86. So we'll measure 43 on our compass. 43. Then we'll put it here because they are sharing the center point. They are sharing the center point. It's still 86, which is 43. So it's here and here. So we'll extend the center line. So now here is what? The diameter here is what is 26. That's the diameter of this. So 26 times half of it is 13. So we are going to what? Use the radius of 13. This radius of 13. So then we'll join this to here is the 25 millimeter line. So we'll join this. Here also we'll join it. Then we'll thicken this. Then we'll join this. So you see from here to here is 50. Then we'll measure 2 here. So I will get this. So here will be 50. You can see that this is 50 already. So to here to the end here is 50 as it is here. So now we'll just draw a line here. Then I measure 2. So we can even do it directly. Let's measure 2 millimeter, which is it here. Then we'll just draw. Then here also. So here is 2. But we need to get the diameter. The diameter here is what? Is 19. Is 19. There are other diameters inside also. So let's get the first one. This is 19. So we'll measure what? 9.5 each. So or I'll just 9.5 here is what? This is 9.5. So I'll just come and mark here. Then this also mark here. 9.5. 9.5. Likewise, here is what? This internal one is the smallest, so it's 16, which is 8. So 4. We'll mark 4. This is what? 4. Then 1, 2, 3, this 4. So this is 4. This is 4, 4. Then the last one is what? Is 26. That's 13. So it will be what? 6.5, 6.5. So we'll measure 6.5 here. Then 6.5. So here is what? This is 6.5. Here is also 6.5. So we'll join them. So here we'll join this to it. Then here also. So we can tick in. So now we have put these two components together, but we need two M10 studs to hold them together. So we'll construct them now. The formula in calculating M10 stud, this M stands for metric 10. So the formula is to get the diameter across flat is equals to 1.5 times this value 10. So 1.5 times 10 is 15. That is our diameter across flat. Then the next one, the width of the stud. And note that this 10 stands for the diameter of the shaft of the stud. So the knot we are going to do, the width of that knot is what? It will be 0.7 times this 10. 7. So it's 7. Then the final one, that's the bottom of the stud. Let me say B. It will be what? 0.1 times this 10. So this is what we're going to be using for this stud. And the reason we're using M10 stud is because we're using half size. So this M20 I divided by 2, so it will be M10. And this one is the diameter of the shaft. So let's start. Diameter is 15, so we'll measure what? 7.5. 7.5. We'll come to the center here. Then likewise here. But first, let's make the centers equal. Let's make the centers align. And here will be what? So this is what? Is 15 and this 15. Good. So now the first thing we're going to do is to, is the distance across flat that is 15 millimeter. And all these units are in millimeters. So then we will take our set square. The distance, this diameter is distance across flat. This is the distance across flat. You can write it here. This is the diameter across flat. So this, I'll draw a flat surface here, then I'll draw another flat surface here. Likewise here. Then I'll take my 30, I'll take my 30 degrees set square. Here is 30. So I'll use it to draw the other sides of the hexagon like this. Then we'll turn it. And note that all these dimensions are in millimeter. So in the same way, 30 degrees. So these are the hexagon. So this is the plan of the hexagon, the top surface. So now the thickness of the knot is 7 millimeter. So we'll come here, we'll project this first here. Let's project all the edges here first. Here and here they coincide. So don't forget the inner circle. Likewise here. So now we'll take this width or thickness of the knot. So, and there's a washer. So the thickness of the washer, we can assume it to be maybe 1 millimeter. Let's assume it to be 1 millimeter. Let it be the same as the base. So 1 millimeter. There's washer. This is the knot and washer. So we are doing the knot and the washer now. So then the washer will end here. Some washers actually extend, but this one, let it stop here. So our washer will end here, will stop here. Likewise here, where this circle is. Then we measure the width of the knot from this point, from the washer here. So it will be from the washer to be what? So from here to here is 0.7. You can see it. Then first we will join to draw the knot. We will join to draw the curves here. We will join this the extreme edge. So to draw these curves here, we will join this extreme edge of this rectangle to a particular point. So maybe let me say the point is here. So we'll join this to here. Then you must join this point to the same place. You see? So now we will take our compass. Then you draw it to the edge here. You see? Then you draw it to the edge here. Then you draw it. So you see? Then in the same way, from this extreme rectangular edge, you join to the other rectangle. You know this other rectangle is before the washer. Likewise, the edge of this rectangle to here. You see? So these points that form V. Then you draw it. Likewise here. So you see, you should stop here. So you draw it from here to here, from here to here. Likewise, you do the same thing here. So likewise, you do the same thing here. So now, we will use our 60 degrees set square to join these edges. You take your 60, you place it here, then you join here. Likewise here. Then you turn the 60 degrees around. The same 60, use it and join these edges. Then you join here. Then you join here. And also this line, you join here. You join here. You see? But don't let it touch here. Then likewise, you join here. Then finally, the thickness of this shaft, the shaft that will draw into this, will be what? Will be 10 millimeter. So, we'll measure 10 here. That's 5, 5, 5. Likewise here, 5, 5. Since it's joining these two components together, it will bolt from here and enter the second component so that they'll be held together. Because you cannot just bolt it to here, no, it won't work. So for these two components to be fixed together, the stud has to extend into this component also from this and has to extend here. So we'll extend it to this point. So it will be from here to here. Likewise. Then also then then this is the base 0.1 times 10, which is 1. So we'll come and measure. So we'll measure here. At this point, we'll measure 0.1 here. Then we'll join it. So this 0.1, we'll take our 60-degree set square. Then we'll draw it like this. Like this then. And then we'll join these two. So this is it. Then one more thing. You can see that here, the diameter here is what? Is 11 millimeter. So there will be a line 11. Here, the shaft diameter is 10. So here there will be something small here, something small to make it 11. Let's measure it. This is what? To make it 11, we'll add 0.5 and 0.5. 0.5, 0.5. So and then here we'll extend it a little bit. Since it's a stud, so we'll extend the shaft a little bit. So now we will thicken this. Then we'll hatch it. Since the sectional question says it's a sectional front elevation on BB. So we are going to hatch it. Since the sectional front elevation, we are going to hatch this. So, but first let's thicken this. So it has been thickened, and now we will hatch it in sectional front elevation. So hatching is usually done in using this 45-degree set square. But sometimes when the parts are more than 2, you can use other angles to hatch it. So now, the first similar component. Since we have joined this component together, this one we will hatch it using the same direction of hatching. Then this one a different one, and this one a different one. You know, when this plan, the sectional front elevation on BB. So this is BB. When this part is cut, this is what you get. But the cut surfaces, we are going to hatch the cut surface. So it's the cut surfaces that we're going to hatch. But here, there will be a space here. So we won't hatch this one. This one will be an opening. So we won't hatch it. Will not, this part will not be cut. This part also will not be cut because it's an opening. Likewise, this part. Even these bolts, they will not be affected by the cut. So we will not hatch them. It's only the cut surfaces that we're going to hatch. So you know that all the surfaces will be cut. So let's start the hatching. So this is the part 1 of this video, of the bearing assembly video. And in my next video, I'll be doing part 2. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.